Hi everyone, my name is Frith and I work for Canadian Wildlife Federation. This presentation is on the elevations of lobster fishery ground lines in relation to entanglement risk to North Atlantic right whales in Atlantic Canada. Requirements for sinking rope between pots and traps in fixed gear fisheries will be implemented after 2022 in Atlantic Canada and Quebec. While inshore state trap and pot fishers in the United States adopted sinking ground line over a decade ago, the majority of Canadian fish harvesters use floating rope between traps and pots. It is commonly perceived that floating ground line between traps floats high in the water column, as shown in the visual on the left. However, the visual on the right represents how fish harvesters believe their lines behave underwater, given that they strive to set their traps as far apart as possible to minimize fishing overlap. I will discuss strategies for how this can be accomplished later in the presentation. Floating line is generally preferred over sinking ground line because lines that float above the seabed are less likely to snag under large boulders or chafe on the seafloor, and floating line is less expensive. The goal of this research is to evaluate the conservation value of transferring from floating ground line to sinking ground line in Atlantic Canada. To do this, we need to know the elevation of ground lines and how often North Atlantic right whales dive to the seafloor. Two central hypotheses were tested regarding ground line elevations. These hypotheses are derived from the two dominant perceptions of ground line elevations as I just discussed. The first hypothesis is that ground line elevations float high, which we define as greater than 3 meters. This is based on published rationale by Brillant and Triple in 2009 that ground lines greater than 3 meters in elevation pose a higher risk than ground lines 3 meters and under, since North Atlantic right whales spend the majority of their time at the surface or in the water column and rarely encounter the seafloor. Should an encounter occur, a ground line with an elevation of 3 meters would pose the same risk as one resting on the seafloor, given the approximate body height of an adult North Atlantic right whale. This makes 3 meters a conservative estimate. The second hypothesis is that ground lines are low, which we define as less than or equal to 1 meter, because that best represents how sinking line is likely to behave, and we can therefore note differences between floating and sinking line. Very little is known about the elevations of floating ground line above the seafloor. The blue stars in the Bay of Fundy show where floating ground line elevations were examined continuously in the water column over a minimum 2-day period on commercially active lobster gear for the first time ever in 2009. Since ground line elevations in fishing areas that coincide with right whale habitat elsewhere in Atlantic Canada are unknown, we chose 2 study areas in the Scotian Shelf and 2 study areas in the Gulf of St. Lawrence. We measured ground line elevation by attaching calibrated DST milli-F depth recording sensors evenly spaced along ground lines within a trawl as shown in this diagram. Sensors were calibrated before each use by holding them underwater at a known depth, and the buoyancy of the sensors was examined to ensure they would not affect the line profile of ground lines underwater. 2 types of ground lines are shown in this diagram, the first being lines between anchors and traps, and the second being between traps. We will focus on lines between traps as they are the most abundant ground line type. In total, we measured elevations of 29 floating ground lines and 2 neutrally buoyant ground lines between traps on 10 different lobster trawls, each consisting of 4 to 15 traps with 14.6 to 27.4 meter ground lines. Trawls were deployed in depths between 4.8 and 73.2 meters for a minimum soak of 24 hours or 2 tidal cycles. We separated the trawls into groups based on ground line length, type, and deployment depth. Here I will discuss only ground lines between traps. Group 1 consisted of floating ground lines deployed in less than 50 meter depth. Group 2 consisted of floating ground line in over 50 meter depth, and Group 3 was neutrally buoyant ground lines in over 50 meter depth. Each ground line was used as an independent test of each hypothesis, and we were able to perform a meta-analysis using a Fisher's combinatorial test to integrate the results and test each hypothesis over all floating ground lines and for each of the groups. It is important to identify here that we have an uneven sample sizes across groups, which is a limitation of our study thus far. Here is a brief overview of the elevations of ground line between traps. Floating ground line ranged from 0 to 6.8 meters with an average of 1.3 meter elevation. Neutrally buoyant ground line ranged from 0 to 2 meters with an average of 0.4 meter elevation. We found that floating ground lines do not consistently remain below 1 meter, but rarely exceed 3 meters, and we found that neutrally buoyant ground lines rarely exceed 1 meter and in this case never exceed 3 meters. The results from this study are very similar to the results from the 2009 study done in the Bay of Fundy, where 92% of floating ground line elevations measured were within 3 meters of the seafloor, with a maximum recorded elevation of 7 meters on a 37-meter long ground line and an average height of 1.6 meters. There are several factors that can influence the elevation of ground lines. Some examples of factors we are looking into as part of our ongoing preliminary analysis are the percentage of slack in a line, the speed and direction of current, and the method that trawls are set. The percentage of slack is determined based on the highest recorded elevation of the middle sensor in relation to the total length of the ground line. Current speed and direction are derived from a program called WebTide, and set method describes the method that traps are deployed. The 2009 study on ground lines in the Bay of Fundy found that current velocity and amount of slack influenced ground line elevation, and found that water depth affected ground line elevation such that they were lower in deeper water. More samples in deeper water are necessary for us to investigate the influence of water depth on elevation in our study areas. Here we have an example of the difference in line elevation between two floating lines from the same trawl. The figure on the left has only 3% slack in the line, and the figure on the right has 14% slack in the line. You can see first that the elevations in the line with more slack are much higher, but also that the current has an asymmetrical effect on lines such that elevations are higher when the current is going southwest, as depicted with negative values on the x-axis, than when the current is going northeast, the positive values. This behavior may seem strange, but we do know that traps rarely land on an even bottom, nor does the current behave the same in both directions, which might help explain what we see in this figure. The table on the left here describes the line elevations from two 5-trap trawls deployed from the same boat in the same area at the same depth with the same types of traps and ground line. The first trawl was set using a roller system, which is shown in the photo on the left. This system is designed to stretch the ground lines out as far as possible before the next trap hits the water. The second trawl was deployed in the traditional method, seen in the photo on the right, where traps are pushed off the rail into the water just as ground line becomes taut. Sensors recorded depth every 15 minutes for 48 hours, and we see that the average elevation for lines on trawl 1 was 0.6 meters with a maximum height of 2.6 meters. The average elevation for lines of trawl 2 was 1.7 meters with a maximum height of 3.8 meters. While we have not yet tested this, these results suggest that the methods fishers employ to set their traps can influence ground line elevation, and with more data we can identify better or worse methods for setting. Bringing it back to the ultimate goal of our research, which is to evaluate the conservation value of transferring from floating ground line to sinking ground line in Atlantic Canada, we have to know not only the elevations of ground lines, but how often right whales encounter the seafloor. Unfortunately, we don't have a good sense of how often this occurs. We know that right whales encounter the seafloor when feeding, exploring, and socializing, and that seafloor encounter rates and durations differ across regions. We know that of all whales seen with mud on their heads, which is 3% of all sightings from 1980 to 2016, the highest minimum seafloor encounter rate was 7.33% in the Bay of Fundy. We know that of 55 right whales tagged in various locations between 2000 and 2010, 1 in 4 dove to within 5 meters of the seafloor. We also know anecdotally that their food source can aggregate next to the seafloor in the Gulf of St. Lawrence, which could mean that whales are feeding at the seafloor in that region. Ultimately, all rope in the water poses an entanglement risk to whales. What remains to be seen is how much of that risk is reduced by switching from floating ground line to sinking line, given that floating ground line elevations appear to be under the average 3-meter height of an adult right whale at least 90% of the time in Atlantic Canada. Entanglement risk is a product of where rope exists in the water and where whales exist near that rope, making low-laying ground lines a relatively low risk. Admittedly, switching to sinking ground line is a relatively easy adjustment, but we would suggest that there are many other elements of fishing, like end lines, that pose greater risk to whales that still need to be addressed in order to achieve much more significant risk reduction than implementing sinking ground line. I would like to thank the Government of Canada as well as Pew Charitable Trust for funding this research. Should you have any questions, feel free to contact me at the email listed at the bottom before or after the consortium. Thank you very much.